Test 6 review here for you. Number 1, solve for k. So you've got this literal equation, which means we have multiple variables, and we want to solve for k. We want to get k by itself. To do that, I'm going to get rid of, by get rid of, I mean move over the m and the j. To do this, my first step, I have to multiply by m and get rid of this denominator. I get jk equals hm. My second step now, I want to isolate k, so that just means j and k are multiplying. I do the inverse and divide by j, and I'm left with k equals h times m divided by j. That's it. There's nothing to simplify or do anything else with. That's the simplified form. Number 2, graph that linear equation. This is just kind of a simple review, getting you to remember that the y-intercept, the b value is -4. So it would start at -4. The slope is +2, which is your rise over your run. So it would go up 2, right 1. I know I'm getting kind of different colors here. Up 2, right 1. And it forms a straight line. And that's what your line would look like. Number 3, what's the solution? So the solution, here we just have one variable, it's x. We're going to solve for x. So what I would do first is I'm going to go ahead and distribute and start simplifying. I'm going to get 3x minus 12. Remember, I've got to stop. That should be a 12. I got to stop where that parenthesis stops. So I do not distribute the 3 with a 6. Here I'm going to distribute the 6 and get 18x minus 24. Again, I stop when that parenthesis stops. Now I'm going to look to combine like terms on the same side of the equations. So I'm going to get 3x minus 6 because I did -12 plus 6. On the right side, I'm going to get -24 plus 12 is -12. Then I just get the variables to the same side. So I'll move it over to the left. It doesn't matter which way you move it. And I get -15x minus 6 equals -12. Let's move this over here. -15x minus 6 equals -12. All right, I'm going to now just isolate this variable. So I add 6, -15x equals -6. Divide by -15, and I get x equals a negative divided by a negative is positive. So I would say 6 over 15. I could simplify that. I could divide both of those by 3. So I could get 2 over 5 is the same fraction. Number 4. Catherine wrote the first step in solving that equation. Which property justifies this step? So if we look here, the 2x is now -2x. The -8 is now +8. It's because she distributed that -1. So that is the distributive property. Number 5, what is the solution to the following equation? We'll do -4, get 5x equals 30, divide by 5, and get x equals 6. Which is a table of ordered pairs defined by y equals -x. So all that simply means is my y value is just the opposite of x. Or one way to think about it is if you plug in, so you can see all these tables, the first input is a -2 for the x. So if I input a -2 for x, I can see that my y value is +2. So this table right here is the only one that would actually line up with, just doing that right there. You could also typed in y equals -x to Desmos, pulled up the table, looked at it that way, but I thought that was easy enough to just kind of look at. 7. What is the solution to the system of equations shown below? So the solution for a system of equations is the point, the x comma y value that they share, so where they cross. So it'd be that point right there that is highlighted in red, which is 0, 3. Number 8. What is the solution to the system of equations y equals 1 half x plus 4 and 3x minus 4y equals negative 12? I would type that in Desmos like it is. And type the second one in, 3x minus 4y equals negative 12. And you can see the point that they cross as long as you type it in correctly. Right there, 4, 6. Number 9, if f of x equals x squared minus 4, find f of negative 6. A couple ways you could do this. You're replacing your x with a negative 6. Make sure you use parentheses. You could type it in your calculator like this. You should get 32. You could also type in, I'm going to do x squared minus 4 on Desmos. Go here, and I'm going to replace one of these x's with a negative 6, and you can see the output is 32. Number 10, write 4 points on that line. We could do this by hand and like plug in x values and get the y and make a point. That would work. We could also just type in the line again on Desmos here. So I'm going to type in y equals negative 5x minus 2. I would just go to the table, understand that those are all points. So negative 2, 8, negative 1, 3, 0, negative 2, 1, negative 7. You could put whatever you want for x, and you can see what that corresponding y value would be. So any of those. There's lots and lots and lots that you could put. 11. What is the y coordinate for the solution to the system of equations below? Again, you could type this one in Desmos. This is set up pretty easily to do elimination, where we could eliminate the variable and solve that way. So if I multiply the bottom by negative 1, I add these two equations, I get 6y equals 12, divide by 2, and I get y equals 2. Again, if you didn't feel confident or you wanted to, you could type it in Desmos and just make sure you're understanding it's the y coordinate. But that one was pretty easy to do without Desmos. 12, sketch a graph that would be a function. You got, lots of things you could do here. That's a function. It passes the vertical line test. Sketch one that would not be. Anything that you draw on a vertical line crosses through more than once. 13, create an arithmetic sequence. Ooh, okay. Arithmetic means that we are adding or subtracting. So you could have something, pick whatever number you want to start with. You could have like 18, 21. So here, if we're adding 3, we have to be consistent. We do have to add 3 every time. We can't jump around. You could have subtracted. You could start with, I don't know, like 20. Let's do minus 4. 16, 12, 8, 4, 0, negative 4, and so on. A geometric sequence means that we are multiplying, whether that be by a number larger than 1 or smaller than 1, doesn't matter, but we're multiplying. So say we start with like, I don't know, 4, and we're multiplying by 2. We'd get 8 and 16 and 32 and 64 and so on. Let's say another example, let's say we start with like, I don't know, what's a good one? 80. And we multiply by 1/2, so it can still get smaller, but we're just multiplying by 1/2 here every time. You can have decimals, no problem with that. 14, what is the slope of that line? Got to get it set equal to y, so it's in slope-intercept form. So I'm dividing everything by negative 4. 8x divided by negative 4 is negative 2x. 6 divided by negative 4 would be negative 1/2 or negative 3 over 2, however you want to write it. Understand that the slope is the coefficient of x when it's in slope-intercept form, so it would be negative 2. The points in the table lie on the graph of a linear function. Okay, so that's a keyword. I know it's linear. Means we have a constant rate of change. Means we're going to have a y-intercept. So what would be the function? So let's write it in slope-intercept form. So y equals mx plus b. Our m is our slope, which is our change in our y, divided by our change in our x. So what I'm going to do first is I will find the change in the y value. You can see we're adding 1. I'm going to divide it by the change in the x value. We are also adding 1. So the slope is just 1. The y-intercept is when x is 0. So I can see the y-intercept is positive 5. 16. The table below shows the relation between the number of hours worked babysitting and the total price. Using the data shown above, write an equation that could be used to predict the total price for babysitting services. Okay, so let's do the same thing that we just did on the one above it. Let's put this in slope-intercept form because you can see we have a constant rate of change. We're going up 20 on the y values. We're going up 2 on the x values. So that tells me that it's linear, so I could put it in slope-intercept form. Slope is going to be our change in our y divided by the change in the x. So make sure you have 20 over 2, which is 10. And the y-intercept is going to be when that input is 0. So one thing you could do is you could go backwards. So we could go minus 2. Let me rewrite this table here. Let me go 4, 43. I could go backwards and I could go minus 2 and keep the same pattern and go minus 20. Get 23 and then minus 2 again, and I can see that's when it's 0. Minus 20 again. I can see that's when the y-intercept's 3. So the total equation would be 10x plus 3. Simplify that. We are multiplying two binomials. I'd use the box method. Combine the like terms. There you go. 18, write an expression that's equivalent to that. Just need to combine the like terms. So I'm going to start with the highest exponent first. That would be the squared. So all my z squareds, 4 squared and 3z squared would be 7z squared. Then all my just regular z's to the first power. So 2z and negative 7z is negative 5z. And then my constants, negative 6 and negative 5 would be negative 11. So just combine those like terms to simplify that. 19, multiply that. So we have a monomial, so just a single one, times a trinomial. With this, you could just distribute it. If you want to use the box method, you could. You just have a 1 by 3. But I'm just going to distribute it and do multiply the coefficients. So 5 times 3 is 15. B times A, it's just A times B. I would leave it in alphabetical order like that. All right, 5 times negative 5 would be negative 25. B times AB. Again, I'm going to put it in alphabetical order. So I'm multiplying an A. I'm also multiplying a B times a B. So it would be B squared. And the third one, 5 times 7 would be 35. And then here, B times AB. Again, I'm multiplying an A and then a B times a B squared. Add those exponents together and you get B to the third. No like terms, nothing to combine, that's it. Create a function where f of 4 equals 8. All right, so we want us to create a function where when we input a 4, our output is 8. Lots of different answers you could have here. Just understanding that like whatever I put for x, so if I'm inputting an x there, I would do like that. That would work. If I put in a 4 for x, that's going to give me 8. If I had x squared, that would be 16. I'd have to take away 8. if I did f of x equals, I don't know, 6x. If I input a 4 there, I get 24. So I'm going to have to do like minus 16. Lots of different things you could have. But just understanding that, being able to create it. Create a table of values that would represent a function and a table of values that would not. So I'll do it this way. So a table of values that would represent a function, let's go like -2, 1, 3, 7. This doesn't matter what we put. We just cannot repeat the x values. So that one, kind of weird looking function, but it's fine. X values don't repeat. The second one, our x values would repeat. So we would have, I don't know, let's go like -2, 4, -2, 8. Doesn't matter what the y values are, but we cannot repeat those x values. A student is solving that problem, x squared plus 14x plus something equals 12 plus something. They're doing completing the square. What number should that student add to both sides? So we want this left side here, we want that to be a perfect square trinomial. So doing so, what would I need to add to that to make it a perfect square trinomial? Well, you just simply take the b value, cut it in half, and get 7, square it, you get 49. So putting a 49 is creating that perfect square trinomial on the left. But we cannot just add 49 to the left side of the equation. We have to also add it to the right. So 49. Corbin solves that by completing the square. X squared plus 6x minus 9. Create an equivalent equation in vertex form. Use completing the square. So I put that there for a reason, so that I think it like actually asks you about the process. Make sure you can do this. So first step, I'm going to move the c value over to the other side and get x squared plus 6x equals 9. I'm going to take that b value. I'm going to get, I'll do it way over here to the right. 3, I'll cut that b value in half, square it, I get 9. So I'm going to add 9 to both sides. I have to add 9 to the left to create a perfect square trinomial. If I add something to the left side of the equal sign, I have to add it to the right. That keeps it equal. The reason I added 9 here on the left, that creates a perfect square trinomial. It's going to factor to x plus 3 times x plus 3, which I can just write as x plus 3 squared. On the right, 9 plus 9 is 18. So the question here is it wants us to get it in vertex form. So it just wants us, like that just, all we need to do is set it back equal to 0. I'm going to do minus 18. I cannot combine it with what's going on inside that parentheses because of PEMDAS. So I'm just going to let that negative 18 hang out there at the end. There's my vertex form. Vertex is -3, -18. To solve that equation for x by completing the square, student could use the equivalent equation blank. Okay, again, still focusing on completing the square. Let's write our steps out. I'm going to go ahead and move that 5 over since I just did an example up above. So I'm just doing -5 here. So that's my first step. Second step, I'm going to take that b value, that -12, cut it in half, and get -6, square it and get 36. So I got to add 36 to here and 36 to here. All right, again, the reason I added 36, that creates a perfect square trinomial. It's going to factor to x minus 6 times x minus 6. On the right side, -5 plus 36 is 31. So we can see here, this x squared minus 12x plus 5 is the same thing as x minus 6 squared equals 31. From there, you could solve for x and get the x-intercepts. You could move the 31 back over, get it in vertex form, but it just wants us to understand and create that equivalent expression. 25. Consider that the quadratic will have blank solutions because the discriminant is blank. So the discriminant is what's inside the square root of the quadratic formula. It's b squared minus 4ac. So if we do that here, we're going to get 6 squared minus 4 times 1 times 9. So that would be 36 minus 36. We get 0. What that means is we have one solution because the discriminant is 0. If the discriminant's positive, you have 2 solutions. If it's negative, you have no solutions. Solve using the quadratic formula. Quadratic formula is on the formula sheet. If you don't remember it, use your notes and also use the formula sheet on the test. But it is, I'm not going to write the whole thing out because I'm just going to fill this in. It is x equals negative b plus and minus the square root of b squared minus 4 times a times c, all divided by 2 times a. All right, so I'm going to start simplifying this. I'm going to simplify the outside and get negative 2. I'm going to do 2 squared minus 4 times 1 times negative 8 and get, what is that, 8, 16, 24, 32 plus, so that's 36. And on the bottom we get 2. All right, I can do the square root of 36. I know that that is 6. So there's my 2 solutions. I'm going to do negative 2 plus 6 over 2, which is 2. And negative 6 minus 6 divided by 2, which is negative 4. What's the purpose of the quadratic formula? Tells us the x-intercepts, which are also known as the roots, the zeros, and the solutions. 28. Determine whether the function below is exponential growth or decay, and find the percent rate of change. We are looking at that number that is attached to the exponent, to the variable. That's less than 1, so it's exponential decay. The percent rate of change. So remember, for decay, it is, we get this number, we get 0.73 from doing 1 minus the rate. And we get that decay factor. So if we do 1 minus that rate, we're going to end up with 0.73. If we solve for x, solve for r, solve for that rate, take away 1, take away 1, you get the rate equals 0.27, which is 27%. If you start with 1, we are going down by 27%. We are left with 0.73. That's what the value it holds on to. It holds on to 73% of its value. It's going down by 27%. Write an equation used to find 3 consecutive integers whose sum is 57. Okay. So I'm going to put first, second, and third. I'll say our first number is x. We have 3 consecutive integers, so that second number is just going to be 1 more than the one before it. That third number is going to be 1 more than the one before it, which is 2 more than the original. So those are our 3 numbers. We know that their sum, which means if we add them together, if we do x plus 1 plus x plus 2, we're going to get 57. So that would be, it just says write an equation. That's all you would do. If you wanted to solve it, you would combine the like terms, get 3x plus 3 equals 57. Subtract 3, you get 3x equals 54. Divide by 3, you get x equals, I think that's 18. So those 3 numbers would be 18, 19, and 20. Graph the following quadratic equation. So this looks like it wants us to graph it kind of by hand. Let's do this. Let's find the vertex, which is negative b divided by 2 times a, and we get negative 6 over negative 2, which is 3. So now the x value of my vertex is 3. This is what we did when we first started looking at quadratics. We put that vertex in the middle, plug in a 3, find the y value. Let's see, that's going to be negative 9 plus 18 minus 5, so that's going to be, I believe, 4. Remember, we're putting that in the middle of the table. For our vertex, we're going to go up one x value and up another, down one x value, down another. This is having to do it by hand. So now I'm going to plug in a positive 4 for the x. So I'm replacing x with a positive 4. And I get a 3. And I know that it's symmetrical, so I know that 2 is going to give me the same thing. So remember that vertex and our axis are as our axis of symmetry. So I know as I go one left and one right from the vertex, I'm getting the same y value. All right, I'm going to plug in a 5 for x. So I'm just going back to that original equation, replacing the x with a 5, and I get 0. Again, I know it's symmetrical. So if I graph this, x is 3, y is 4 is my first point. There, there's my general parabola, and pretty good for me. If f of 7 is equal to 40 times 1.65 to the 7th power, what gives f of x? Well, notice the x is what replaced the 7. So f of x, I'm just going to replace the 7 and keep everything else the same. Ta-da! It's kind of like the reverse way we normally do it. All right, last page. Table value just shown for f of x and g of x. This is going to be a nice tough question. Based on the given data, when do g of x and f of x intersect? So when do they cross? All right, so if I look at when x is 0, f of x is at 0. Let's do this. Let's make kind of like sketch a graph. All right, when x is 0, I know that f of x is at 0. Let's make this one red. Let's make this one blue. I know g of x is at -2. All right, when x is 1, let me make some actual notch marks here. 3, 1, 2, 3, 4, 1, 2, 3, 4. All right, when x is at 1, the f of x function is at +1. Okay. For g of x, when x is 1, the y value is -1. All right. When x is 2, the y value is 4 for f of x. And when x is 2 for g, the y value is 1. So 2, 1. All right. When x is 3, the y value is 9. Ooh, we're out of space here. So let's see if I can actually extend this up and possibly make it into 9. 5, 6, 7, 8, 9, maybe. All right. Hopefully I'll get the understanding of this. It's just I'm trying to create a visual. For g of x, you can see when x is 3, the y value is 5. So this whole time, like, g of x is below f of x. But if I'm going to kind of skip down here, if you look when x is 5, now suddenly the g value, the 29, is higher than the f value. That's the first time that happens. That means between 4 and 5, somewhere between 4 and 5, when x is 4 and 5, those two lines cross somewhere between us, because f of x went from being above g of x the whole time until x was 5. They crossed over. 33. Consider this function for cell duplication. The cells duplicate every minute. The initial value is 40. We started out with 40 cells. How many cells are there after 1 second? Replace the x with a 1. So you say, how often does the number of cells double? Every 1 second. Oh, I see. Oh, I think we used most of the question for this isn't good. We used most of this question from the test, and we forgot to change the units. Let me rewind on this. Sorry. All right, the initial value is still 40. That's still correct. It says the cell duplicates every minute. So we didn't write this very well. I mean, technically that they're doubling every 60 seconds because it says duplicating every minute, which is 60 seconds. How many cells are there after 1 second? It's not like this on the test. I think it's like how many are there after 3. Like if it gives you minutes, it says how many are there after 3 minutes, something like that. I guess technically the mathematically most correct answer would be if you did in a calculator like this and you did 1/60, because they double every minute. So 1 second would be 1/60th of a minute. So I can tell what the actual answer is, but this is not how it is in the test. I mean, there's 40.46. That's a terrible question. I'm sorry about that, but I don't even know. My bad. An object is thrown in the air with an initial velocity of 5 meters per second from a height of 9 meters. The equation represents the height of the object in meters after t seconds. About how many seconds does it take for it to hit the ground? So we just want to know when it hits the ground. We're looking for the x-intercept, the positive 0. So let's go to Desmos. Let's type that in. Negative 4.9x squared plus 14x plus 4. You can see it hits the ground after about 3.119 seconds. $35. What is the vertex of that graph? I mean, you could find it by hand, but I just type it in Desmos. Why not use that tool? So we've got x squared plus 4x minus 8. Vertex is -2, -12. Last one, the expression right there represents a company's profit for selling X items. For which number or numbers of items sold is the company's profit equal to 0? This is just like questions you would see on Delta Math. Again, I'm going to type this into Desmos. Plus 194x minus 5040. All right, so it wants to know when the company's profit would be equal to 0. We can see here, kind of like, I'm going to reshape this graph. There's your parabola. The company's profit is the y value. Since the x value is the items, the y value is the profit. So this company's profit would be 0 when they sell 28 items and 360 items. Anything between those two, their profit is greater than 0. Less than 28 or more than 360, their profit's negative. But the profit is 0 at 28 and at 360. Well, that's it. Good luck on your test. You got this one and one more with a review, and then we have a couple with no reviews, and that's the end of the semester. So good luck. Anything you notice that was messed up or any questions you have, let me know.